Okay, have a look at this question. Okay, pause the video if you need to, read the question, and I'm going to answer it. Okay, so what we need to find the power loss. Okay, so the power loss is the resistance is 2, okay, and the current is 30 amps. So simple equation. Typing all the numbers, and we have 180. Sorry, 1,800 was power loss. Okay, down. Okay, now look at. Let me enlarge it. Look at this question for a minute. Okay, we need to find the voltage in the house. Okay, so the idea is treat it as a series circuit. Initially, I have 240 volts as a power supply. The wire, okay, has a resistance of this. Okay, so what I'm going to do is the voltage at the house will be basically 240. The voltage at the supply, take away the voltage drop. Okay, the voltage drop is basically V equals to IR. Okay, the current times the resistance of the wire. Okay, the voltage used by the wire. Okay, 30 times 2, which is 60 volts. So if you do it, okay, you have 240 take away 60, which is 180 volts. Okay, because the owner doesn't want to use a transformer. He do that, it's over a kilometer long, it doesn't work. It just doesn't work. Now look at this question. So in this question, we need to find, okay, again, we're looking for power loss. I equals to R. So the current is this, and if you have a read, okay, the resistance is this. Okay, it's the it's the resistance between the wires between T1 and T2. Okay, so type it in your calculator. You have 41 watts. Okay, remember the unit. So here is another question. Now this question a little bit different, but similar. It has a similar concept. Okay. Now, okay. So we have a voltage, and we have a power. Uh, we have a 3 ohm resistance. Okay. So what is the power of that light, that device? Okay, so use the equation, the power used will be I square R, but we don't have current, so what we can do is V square divided by R. If you don't have this equation, write it down. So normally we don't use it, but if we don't have current, we use that. So, yep. Okay. Just remember with power transmissions, we don't normally use that, but sometimes it's just like a circuit. If we use this part, so if you have the equation in, which is 12 volt square divided by 3, you have 48 volts. Okay. Or what you can do is, you can still use this part of the equation, but we need to find the current first using V equals to IR. Okay. So voltage is 12 times the resistance 3, current is 4 amp. Okay, if you use that, again you get the same answer. Okay, this is the power used by the device. Now, okay, continue with the previous question. Okay, this time, he connects the lights with a long wire. Okay, each wire has 0.5 ohms of resistance. So what is the voltage across the light? Okay. So the voltage, remember a voltage divider? Okay. The voltage across the light, okay, will be 12 take away the voltage across R1 and the voltage across R2. Okay. So it's going to be 12. The current was 4 amps. No, the current is not. This time, let me have a look. No. Okay, it's 0.5. So, yep. So we have 3 ohms here. It's just treat it like a series circuit. Okay. The total resistance is going to be 4 ohms. Okay. V equals to IR. Current is going to be 12 divided by 4, 3 amps. So the voltage across the light will be 12 take away the voltage used by this, which is 0.5 times 3, and used by that, which is 0.5 times 3. Okay, so it's 12 take away 1.5 take away 1.5. So it's going to be 9 volts. Okay, or you can use a power divider equation. So voltage of light must be the total resistance and the resistance of the light times 12. Okay. Because this is a series circuit, so I have 3 on 4 times 12, which is 9 volt. Okay. You get the same answer. Now, again, last question. So what is the current? They ask me the current flowing. Okay. So treat this as a series circuit. Okay. I have 3 ohms here, 3 ohms here. Okay. So this is parallel. So if I combine them, okay, if I combine these two into one big circuit, okay, the effective resistance will be 1 on 3 plus 1 on 3 bracket power of -1. Don't forget that. It's going to be 2 on 3 power of -1, which is 3 on 2 ohms. Okay. Then the total resistance will be 0.5 plus 0.5 plus 3 on 2 ohms, which is 1.5. So you have 2.5 ohms total. V equals to IR. V. Okay. The total current will be the total voltage divided by the total resistance, which is 12 divided by 2.5, and we have 4.8 amps. Okay, done.